can't really find the one end. And so what we do is we make a table called membership. And in that table of membership, we actually often don't put a primary key in at all. We simply put in 2 foreign keys. And if we're going to put a uniqueness constraint, we put a combination of the 2 foreign keys as the uniqueness constraint. So we say there can be duplicate user IDs and duplicate course IDs, but there can only be, user ID, course ID combinations. That has to be unique. So you can make unique be more than one column. And so if you imagine a course table and a user table, there's a user ID, the name and email, and the course has a title and an ID. And then we have this little table that just is the connector table that shows the points out. And so we can expand this membership. So let's take a look at how that works. So we're going to create some tables, and these are very classic tables because these are the one end of it. So these are the one end of it. So it has a primary key, a title, a logical key, email. There's a primary key for course, and then there's text. So we add this unique to kind of indicate that it's a logical key. We're not going to allow ourselves to put any duplicates in here. Now the connector database here is a table member, and it has 2 foreign keys, user ID and course ID, and you can even model some data here. So I'm going to model role, which is going to be 0 equals student and 1 equals instructor. And then I'm going to indicate that the primary key or uniqueness constraint is the combination of the user ID and a course ID. Now when we say the primary key, it both limits our ability to insert duplicates, but it also allows the database to optimize its scanning because it knows that that combination is always unique, and so it can organize its disk structure and storage structure to understand how to look things up more efficiently, knowing that once it's found a user ID, course ID combination, it doesn't have to look any farther because they're unique. And so all of these contracts that we add speed things up, save storage, and makes things more efficient, but in ways we don't always know exactly how they happened. And so let's go ahead and make these. Let's go ahead and make these guys. I think I will start with a new database. I'm going to call it LMS for Learning Management System. No, I don't really want to do that one. And so I'm going to not create the table. I'm going to do everything in SQL. And so let me see if it's in my cheat sheet. Nope, that's not in my cheat sheet. So I'll have to fix the cheat sheet again for you. By the time you see the cheat sheet, all these things will be in there. So I'm going to go in here and I'm going to grab create table user. Actually, I'm going to grab them all. Watch this. Grab them all. Highlight all these. Go over to SQLite browser. Blast them all in. And then I'm going to put a semicolon at the end of each one of the statements. And I'm going to run them. So does it look good? Yep. So I got a course, I got membership, 2 foreign keys, and I got user. So that all looks good. Okay, so now we're going to have to insert some data in. And we're going to insert from the outside in. And so we're going to just put the name and email. The ID will be automatically assigned for the users. And we're going to do the same thing, and the ID and the courses will be automatically assigned. So let me just grab all this stuff. Go into SQL. That has the semicolons at the end already for me. Thank you very much. Now I'm going to run it. And if I take a look at my data, now I've got primary keys for the courses, and I've got primary keys for the users, and I've got nothing in the membership table. And I of course have to remember what these values are because Jane is 1 and Ed is 2 and Sue is 3, right? And Python is 1, SQL is 2, is 3. And so when I go into membership, I've got 2 foreign keys here and a role, and they just have to be for the course person combination. And so it's a little tricky to figure all this stuff out. But again, these are just numbers, and if you look at these numbers, user ID, course ID, role, well, user ID 1 is in course 1, user ID is in course as the teacher, user ID 2 is in course 1 as the student, etc., etc., etc. So I'm making these connections by just putting these little numbers in, and once again, conveniently, I have all my semicolons perfectly in place. So I go to SQL, and then I run that, and then I take and I look at my membership data, and there it is. So 2 foreign keys and a bit of data modeled at the connection. That's the way we say that. The role is modeled at the connection. So now we build all this stuff up, we can write some queries that take a look at this. And so what we're going to do is we're going to look at who's in what course and what role are they, and we're going to sort this in a nice way. So let's just take a quick look at the code we're writing. We're going to do a select from 3 tables: the username, the member role, the course title. So in effect, we're not showing any of the foreign keys or the primary keys. We're going to go from the user table, join to the member table, join to the course table. This is pretty easy to write. You know there are 3 tables you want to go across. The on clause is also very easy to write, right? The on clause models each of these connections, where the member's user ID is equal to the user's ID, and where the member's course ID is equal to the course ID. So we're going to concatenate all 3 of these tables together, but we're going to only keep rows where it matters. Now that this role doesn't participate, but we're going to print that out. And we're going to order it by the course title first, and then the member role second, and the name third. And so let's run that. So we've reconnected it. So Ed's the teacher of the PHP class, Sue is the student in the PHP class, Jane is the teacher in the Python class, Ed's a student, and Sue are students in the Python class. Ed's the teacher in the SQL class, and Jane is the student in the SQL class. And so we have many people there are many students in many classes there, and so we have modeled that, but we model that with this sort of table. And if you look at a piece of software that I've written called Sugi, which is a standalone learning management system that's built with learning tools, you will see in anything where membership, where we have a user table, we have a context, which is also the course table, and then we have a membership table. And you look, here's these foreign keys. It's kind of like that's the many side, that's the one side, many to one, and so this, this is now in effect a many to many between these two, but then it's modeled as a series of many to one relationships. And you see this all the time in all kinds of things where membership or other kinds of things are necessary, many to one, or many to many. So, with all that, there's so much to learn. It's both easy and complex at the same time. It's easy when someone shows you how to do it, but at some point you will learn how to build database models and you realize, oh, it wasn't so bad. It takes a while to get used to them. This really just is a quick walk. But the bottom line is what we just did seems like it was, wow, that's nice. Do you really have to do that? And the answer is, if you're going to scale at all, you absolutely have to, because you simply can't read and write data sequentially. You can't read through, update one little piece of data in a file by reading all the way through and then writing a new copy of the file. That could take seconds. And in a system like an online system, you get 1/100th of a second to do something like that. And the databases make it so that happens in 1,000th of a second. So ultimately, you simply have to take advantage of this. You just can't, if you're going to modify data, you can read data from flat files, but even if you're going to read a lot of data, if it's big, it slows down terribly. So it might seem like there's a trade-off that you could debate whether this is worth it. But if you're going to deal with a lot of data, you've got no choice. It's really not as much a trade-off as you think. So this has been a quick romp through databases. We talked a little bit about indexes. There are constraints. We talked a little bit the not null stuff. We've talked about that. Uniqueness, that's a constraint. Another whole area is what's called transactions, and that's the locking of little areas, so you can read an area, then lock it, and then update it to make sure no one else reads it. And so they make sure they either get the version before you looked at it, or before you change it, or after you change it. And so that's how you make sure that you can't do things having to do with bank account balances and get yourself in trouble. So these are a lot of SQL. It's really fascinating. SQL is a fascinating thing to use and learn and performance tune and enjoy. So relational databases are cool. This gets us started. The big thing is don't allow replication vertically of string data. Pull that out into a separate table, establish a primary key, and then have foreign keys that point to that primary key. It is not just how much data you store. It's sort of a compression way, as a way of compressing data. You might think strings take no data, but they do. Numbers take a lot less data, and it's both how much data that's stored, but also how much data has to be scanned. And that way joins work. That's part of the magic of why Oracle is such a successful company. It's a bit of art form, and it's something that you can work your whole life and always get better at.
Hello and welcome to our code walkthrough on the roster code. So the learning objective of this is to do a many-to-many table. And so the idea is that we're going to, just like we talked about in lecture, we're going to have a set of users, we're going to have a set of courses, and then we're going to have a connector table or a many-to-many table that basically has two foreign keys. So we are going to use the integer not null primary key auto increment unique as the way to get auto assignment of the primary keys in the user table and the course table. And then we're going to say that the name, which is like a logical key, and then the course title, we're going to mark those as unique. And we're going to take advantage of that in a moment. And so you'll see how we take advantage of that. So what unique means is if you try to insert the same string into this column, like Chuck twice, then it's going to fail the second time because it's going to refuse to create a new record. And so if we just kind of like take a look, we're going to get our roster data from this sample JSON, which is just an array of arrays. And this is the person's name, the class that they're in, and whether they are a teacher or a student. And so we're going to read that. So we need the JSON library and the SQLite library. We make a database connection and we get a cursor. The cursor is kind of more like the file handle. You send SQL commands to the cursor and then you read the cursor to get the data back. The connection can create more than one cursor so you can have more than one set of commands. But the cursor is generally like the file handle to the database server. And we are going to execute a big script, and you'll notice this is a triple quoted string that goes all the way down to here. And so some people would just give this to you in a text file and have you cut and paste this and then go run that in your SQLite browser to create them. But that's okay, because what we're going to do is we're going to set this up. It will either reconnect to existing file name rosterdb.sqlite, and if I look where I'm at, I do an ls, we find that that file is not there. So the first time I run it, it's going to create it. But I want this to start fresh every time, so I'm going to wipe out the tables if they exist. That way you can run it over and over and over again in case you make a mistake here. Now I don't have a mistake, or hopefully I don't have a mistake on this. So we're going to drop 3 tables, and we're going to create 3 tables. And here we're going to create the table that has 2 foreign keys, user ID, course ID, that are sort of going outwards from the member table. And then we're going to model a little bit of the data at the role. And again, this is straight from the lecture. And the primary key is actually a composite primary key, because we're going to look up, and it's going to force this to be the combination of user ID and course ID to be unique. But there can be many user IDs and many course IDs, but only one particular combination of a value for user ID and course ID. And so that's what we're basically saying. You can be a member of a course, but you can only do that once. You can't be like a member of the course a bunch of times. So we're going to, that should be roster data sample. That's okay to, fix a bug. Save that, roster data sample. And so that's just this file, and it's really just an array, and then each row is an array, and it's a way for us to get this roster data in. And so once we do load S on JSON, we're parsing it, and then this is going to be an array of arrays. And so for entry in JSON data, so entry is going to be one of these things. So entry itself is a row. So an entry sub 0 is the name, and entry sub 1 is the title. Name, that's the sub 0, and that's the sub 1 of the particular entry that we're looking at. And we're going to print it out just for yucks as a tuple. So we make, that's what the two parentheses are. This inner thing is a two tuple. And we're then going to take the person and we're going to do an insert, and this is new, or ignore. So what the or ignore means is if this insert would cause an error, please don't blow up. Don't just ignore that I tried to insert it. And so this is our trick, and it's a beautiful trick. It's like a gorgeously beautiful trick. Here, if we insert the name Chuck twice, or ignore will just mean that nothing happens, meaning it's already there. Okay, so if it's already there. If it's not there, it'll put it in. And the unique will guarantee that it only goes in once. So we just, in effect, always attempt to insert it. And if it's been there once, then it's all set. And so this insert or ignore is a super powerful mechanism. I use it all the time. And we have a placeholder in the form of a question mark, and then we have, so one of these days we'll have two things that we're asking for. As a matter of fact, here it is. There's a tuple down here, but this is kind of a tuple with one item in it, name, and that name is then going to substitute in for there without, while avoiding SQL injection. So this runs. It may or may not insert a new record, but if this Chuck or whomever the name is not there, it will give us a new record. And then we are going to get back the ID. And so this is the logical key and this is the primary key. That primary key is going to be auto constructed for us. And so we need to know what it is. So we say select ID from user where name equals and then that same name. So that's Chuck. And so that gives us one. And then what we do is we're going to fetch one record from the cursor because that's a select and it gives us back a cursor. There's only hopefully one record there because it's unique. I could put a limit 1 in there, but that'd be kind of redundant because it is the name is a unique key. And then the sub-0 just means if there were more than one thing that I was selecting, which we'll see in a bit, the sub-0 is just the first thing. And so this is going to give us the integer user ID that was assigned, or if we're coming through later, for Chuck, Chuck later, Charlie later, that will be the old one. So this is inserted if it doesn't exist, and this is get the newly created ID field or the original ID field. And so part of this works by having both a logical key and a primary key. The primary key is auto-generated, but the name is a logical key and it's unique. And so that's our trick to get that assigned thing. Before we just looked at it in the user interface of SQLite browser and wrote it down. But this is how we do it in code. So we need to know what that key is, whether it was new or not. And then we do the exact same pattern for the course, except we're inserting the course title. So that's no big deal. And so we're going to get the user ID, course ID. And then what we're going to do is we are going to insert or replace. So this is it basically, remember that this user ID course ID combination is the primary key for this member table. If there is a duplicate, if this combination is already there, this becomes effectively an update statement. And we have these two number values. Now what's missing here is the role is not there. And so user ID, course ID, this is the SQL bit. And now we have a tuple with two items in it, and that's because we have two question marks. And then we commit it. And as I mentioned before, sometimes you want to commit every time through. The commit it turns out that these things are less costly, but that's because it's not always writing all the way to disk. Whereas when you enter the commit, it's going to go and write everything to disk, pause until it's complete, and then your program doesn't continue. So sometimes we don't run this every single time through. Okay, so let's just go ahead and run this. The only thing we're going to see is the output of the name and the title as it's running. So if I do Python 3 roster.py, hopefully I can hit enter. So you'll notice, by the way, that this SQLite now exists, right? And it has no data in it. So let me see if I can open this database and see it. So you see that there's no data. So we're the code, we've run this code in effect up to this point. So we've done all the create tables and all that stuff. And so the create tables are there. So all this data is here. It did it. We haven't started putting any data into it yet, because if we look at browse data, we're not finding anything in here. Okay? There's no data to browse. Now, hopefully we won't have locked ourselves, because we are sitting right here, and when I hit enter over here, then it's going to go, it's just going to run really fast. So I'll hit enter, it'll read it, and so it inserted all of those things, and now it's been changed. And if I hit refresh over here, we will see in the user it just sort of assigned user IDs, right? The columns auto-assigned. We will find in the course that those courses are all auto-assigned. There's the courses, and there's no duplicates because this is unique, right? And so these are the newly created things. But then membership is user ID, course ID. And so again, the primary key, as it were, the unique constraint / primary key is the combination of these things. And I haven't put anything in role. And so if you scroll through these, you see all of the users who are members of the courses that they're part of. Okay? So there you go. And I'll leave it up to you to come up with the join. I'll leave it up to you to figure out how to put the role in, but I just wanted to kind of give you a bit of a walkthrough of this code base, and in particular, the tricks of the uniqueness keys, the auto increment keys, the logical key uniqueness, and then this kind of composite primary key, and then the trick of insert or ignore, and then the quick select that comes right afterwards to get the newly generated ID or to get the old ID. You can insert or sort, and then insert or replace, which is a combination of a insert and an update. So I hope you found this this example useful and can apply it and basically create many-to-many tables. We are doing some code walkthroughs. If you want to follow along with the code, you can download the source code from Python for Everybody, the Python for Everybody website. Okay? So the code we're playing with today is twfriends.py, and this is a step beyond the simple TW spider. It is a restartable spider, but we're going to data model things a little bit differently. We're going to have two tables, and we're going to have a many-to-many relationship, except that it's sort of a many-to-many relationship between the same table, which is okay. Friends is Twitter friends are a directional relationship. And so we start out here in twfriends.py. Remember that the file hidden.py, I'll show it to you, but I'm not going to open it because I've got my keys and secrets in it. So this hidden.py file, you got to edit that, and you got to go to apps.twitter.com and get your keys and put them in there. Otherwise, these things won't work. But if you have Twitter and you set your API keys up and you put them in hidden.py, then all these things will work. It's kind of fun, actually, and impressive. Not hard to do, actually. So the Twitter URL, that's my library that reads hidden.py and augments the URL and does all the OAuth stuff. JSON and SSL because because Python doesn't accept any certificates, even if they're good certificates, so we kind of crush that. Here's our friends list that we're going to hit. We're going to make a database, friends.sqlite. Now here we're doing create table if not exists. So what this really is saying is I want this to be a restartable process, and I don't want to lose the data. We're starting out, we do not have SQLite, any SQLite files, and so this is going to create the database and create these tables, but the second time we run it, we're not going to recreate the tables. We're going to be able to restart this because we're going to run out of rate limit before we finish this, but so we just have to wait however long the rate limit takes to reset, and we'll watch the rate limit go down. And so we're going to have a people table, and we're going to have a primary key and the name. The name is going to be unique, and whether or not we've retrieved it, and that's kind of from a previous one. But then there's the who follows who, the from ID to to ID, and so this is a direction, and we're going to put a uniqueness constraint in, just like we do in many-to-manys, that basically says the combination of from ID and to ID has got to be unique. We don't allow ourselves to put duplicates of the combination. So from ID can be 1 in many records, and to ID can be 1 in many records, but 1 is only allowed once. And this is the crud we have to do to convince Python to accept the Twitter certificate. And so this is similar to some of the other stuff that we've done. We're going to enter a Twitter account or quit. And if we hit enter by itself, then we will actually go and retrieve a record that was not yet retrieved. And now we're actually pulling out two values, ID and name. And so we will grab fetch one is going to give us a two tuple basically, and we're going to store that in ID and account. Of course, that's like this is coming back with a two tuple, first of which is the ID from the database. Limit one means we're only going to get one of these or zero of these. If there are zero of these, that means there are no unretrieved Twitter accounts. Retrieved equals zero. Well, you'll see in a second that all the new accounts we put in are the ones for which we haven't retrieved. And again, given that our rate limit, we want to know which ones we've retrieved. Okay, and so what we're going to do next is we're going to check to see if the person that we just checked, which means the length of the account is greater, that we just were entered, we're going to check to see if they're already there. Okay, and we're going to select ID from people where name equals, so that's the one we just entered. And we're going to fetch one and grab the first thing because we only got one thing in the select statement here. And if this person that we just asked to see is not in the table, that means this is going to fail. We're going to do an insert or ignore. This or ignore is kind of redundant because we just checked to see if it was there, but we'll put that in just to be safe. And we're going to put the name in for as the new account that we're looking at, and we're indicating that retrieved is 0, so that we will know that we haven't retrieved it yet. You'll see that we'll update that in a second. We commit it so that later selects will see this. So you got to do the commit. This later select wouldn't see the one we just inserted, and we're going to ask how many rows were affected, and if it's not equal to 1. Then we're going to complain about we inserted it, and we are going to do this thing. We're going to ask, hey, remember there was an ID up there? Right here, ID integer primary key, and we did not insert this here, but we want to know what that ID is. And every time I was showing you that in lectures, I was saying it's really easy in Python to do this, and that's what we're saying is this cursor did the insert, but one of the things happens is after the insert, we're going to grab the last row ID, which is the primary key that was assigned by SQL. Okay, and so that means that one way or another, coming through this code here in line 45, one way or another, we're either going to know the ID of the user that was there before, or we just inserted one, and so we're going to know the primary key of the current user, and you'll see why we need that. So ID is the primary key of the current user that we entered right here. Okay? And now what we're going to do is do the Twitter URL augment with the OAuth and all the keys and the secrets and hidden.py. Instead, we're going to go through, let's count 1,000. Let's go count, what the heck, let's go 200, up to 200 friends. Save. No, let's do 100. We'll keep it that way. And then we're going to retrieve it, and we're retrieving the account. We're not going to print the nasty URL out. We could. Then we're going to open the URL with a connection, and then we're going to read that, and we're going to get the UTF-8 data from this, and then we're going to decode that, and we're going to have the Unicode data. So the data string is a internal Python string with all that data representing all the wonderful characters. And of course, we're going to ask URL open to give us back the headers as a dictionary using this call, and we can see what how many we have left for the remaining, right? What's the remaining rate limit that we have, okay? And so then what we're going to do is parse the data with JSON load S. If, oh wait, I need a continue in here. Continue, okay, save. If we are going to parse this data, we'll print it out, right? So that means that this died, which means it's not syntactically correct JSON, basically. And who knows if we're ever going to see that, but at least when it blows up, it'll print this data out. We'll have to catch it, and then it'll continue. Actually, I'll make this a break, because if that's blowing up that bad, we should quit. Now, I don't yet know what happens when this rate limit says you can't have it, and so, but I do know that I expect when it's successful that there will be a key of users in this outer dictionary that we're going to get, and if this outer dictionary that if users is not in the parsed dictionary, then I'm going to dump out this data so that at least I can debug what happens when I've got some broken JSON. So the difference between this code This code is going to fail when the JSON is syntactically bad, meaning a curly brace isn't right or whatever. This code will trigger when I get good JSON, but I don't have a user's key in it. Okay? So then, once we've retrieved it, we're pretty happy with it. We're going to update for our account that we are retrieving. We're going to set this is one of our retrieved accounts. Okay? And then what we're going to do is write a loop that goes through all the friends of this particular user that we're asking and gets their screen name, prints it out, and then we're going to check to see if this one is already in our people database, because this is a spider. We're grabbing accounts, and so we'll do a friend ID and do a fetch one, grab the Sub-Zero thing, and if that works, if this person's not in there, this fetch one is going to blow up, which means we're going to drop down to the accept code. But if it does work, we have friend ID is the, that they're there and they're already in our database, right? They just weren't retrieved. Okay, and so now if the friend ID wasn't there, we're going to do an insert into setting retrieve to 0, and then we're going to commit, right? Now, remember, row count is how many rows were affected by this last transaction, cur.row count, and we're going to die if that insert doesn't work. This is unlikely, unless somehow we've ran out of disk drive or something. And we're going to grab the friend ID as the key, the last row that was inserted. We're only going to insert one row, so it's basically the primary key of the row that we just inserted. So if you look at this code right here, it comes out the bottom one way or another with friend ID successful, right? Friend ID is either they're already in our database or they're not. And if we insert them, then we have it. And so now, this count new and count old is just so I can print out a nice printout. Now we are going to insert into the friend table, which is called the follows table in this case, from ID and to ID. Those are the two outward pointing foreign keys. And we have the ID of the account that we are retrieving the friends of, and then this particular friend. And so we're inserting the connection from this person to that person. And then we commit it. We want to commit these again so that later selects, when the loop goes back up, later selects get all of that data that's going on. Okay, so we do want to commit from time to time, and then we close the cursor at the very end. Okay, so let's run this and see what happens. Okay, so Python twfriends.py. Oh, of course, I am a refugee from Python 2, so I always forget to type Python 3. Okay, so we're going to start. If we take a look right now, I'm going to start another tab over here, and ls-l star SQLite. Now that SQLite file is there, right? And it's actually made the tables. If you go up here, it ran all this stuff. Create the tables, yada yada, and we're sitting right here at this line. As a matter of fact, I think without causing too much trouble, I can open that database and get into this database right here, and there is no data in the follows table, and there is no data in the people table. It's completely empty, okay? So we're waiting for the first one, and I'll go with mine, Dr. Chuck. So it's retrieving the 100 friends, and they all were brand new. They're all inserted, right? And so now if I hit refresh, we will see that Dr. Chuck is retrieved. Who follows? So these are all the people I follow. So one follows two. So if we look at here, we see that Dr. Chuck follows Stephanie Teasley. Because we grabbed the followers of Dr. Chuck, we're going to have a record in all of the follows for all the ones that I did, right? So these are all the people I followed, and we put them in. Okay? So we can go back, and we can, let's see, grab somebody. Let's go grab Stephanie Teasley. And let's pull out her friends. So we grabbed 100 of her folks. I got 14 left. That's my X rate limit. So I did Stephanie Teasley. So let's go back here. So you'll notice there's 101. There's probably going to be, 182. That's interesting. So we've retrieved Dr. Chuck and Stephanie Teasley. And let's go take a look in the friends table, the follows table. Okay. So we have all of the people I follow, now all the people Stephanie follows. Okay, so there we go. So let's go ahead and do somebody else. Let's see, I think we both follow Tim McKay. Where's Tim McKay? Yeah, let's follow Tim McKay. Let's see who Tim follows. See if we can get like an overlap. Oh, we revisited some. Let's see if we can see this in the follows. Let's see people. So we've got Dr. Chuck retrieved and Tim McKay's somewhere down here. You know, it might take us a while before we get any really good overlaps. Let's see. Let's do a database call. Let's see, let's do a database SQL. Select count Okay, so let's just run this some more. It's clearly working. Now, one thing I can do here is I can hit enter and it will just pick one randomly. So it grabbed Live EDU TV, and now I can, and let's see how many I got left. We got 12 left, and now I can hit enter again and it picks another one. That was the next one. I was kind of picking them in order. Is it picking them in order? Let's go to people. Yeah, it's picking these. So it's gonna, we can see that it's gonna just do the first unretrieved person, who's Nancy. Let's let it retrieve Nancy. So it grabbed Nancy, new. So we're finding some, and this table's getting really big. And so if we look at the people table, we now have 455 people, and we have 467 following records. And so there we go. Oops. Hit enter, it does another one. And away we go. So you get the idea. I can type quit to finish. And just to give you a little interesting bit of code to show you how to do selects, I'm going to do this TW join. Now you'll notice that we're not talking. Oh, let's show you one thing. ls-sl friends star SQLite. So this database has it, so I can restart this process and run it again, and the database is still there. And so we just grab swear trek and so we can keep doing this, and so this data, it keeps extending, and so this is a restartable process. I can run it and then tell it to grab the next unretrieved one, and so away we go, right? And so that's part of it. So I can, if I run out of my, I've got 8 left. Oh, how many do I have left really? Let's keep going. How many do I got left? I got 5 left. Okay, wait. Oh, I guess we'll just run it out. So I got 4 left. You know what I should do is I can't change the code. Yes, I can't change the code. I can stop the code and I can quit the code. So what I'm going to do is I'm going to change this code a little bit really quick. And I'm going to print the headers of rate limiting at the beginning and at the end. So now I can run it again. I changed the code. Hopefully I didn't make a Python error. Tell it to go get another one, and a Navarro. And so I got 3 left. Oops. We'll see what happens when I run out of rate limit. Run out of rate limit. So we have 1 left. Hit enter. Hit Control K. Opensource.org. So we have 0 left. That worked. Now let's see what happens. I don't know what happens next. Oh, we blew up. Too many requests. Oh, we got an HTTP error 429. So that means that, going for Mark Cuban, that was in line 48. So the right thing to do would be in line 48. We should really put this in a try except block. Try except block. because it gives us an error. Print, oh fiddlesticks. How do I print the exception message? I always am forgetting. Print failed to retrieve. Okay, so we'll put that in. Now if I run it, oh, and then I have to put a break here because that's not good. Break. Failed to retrieve. Now I got to figure out, oh, I never know how to print out the error message. Yeah. So I have to, I never see, that's the weird thing about stuff, is that I don't ever remember enough. I don't remember the syntax, what I say here, to print the error message out. So I'm going to go to Google and I'm going to say print out the exception message in Python. Print out the exception message in Python. Oh, Python 3, hello. Okay, so let's go find it here in the documentation. Accept. Is this it? Is this what I say? I just want to print out the message. Ah, that's it. Accept. Let's try this. So this is part of Python programming, is like, for me at least, because I'm just not like a genius expert at this stuff. Ha! This is one thing I like about Python, is you can guess stuff, and sometimes you guess right. So there we go. We got the error, we got the nice little error message, and we see error 429, too many requests. So that cleans that up nicely. So we have run out of requests, and on that, it is a good time to say thanks for listening, and I hope that you found this valuable.
Hello, and welcome to our final chapter, Retrieving and Visualizing Data. In this chapter, we are going to basically bring this all together. Databases, web services, code, loops, logic, and we're going to solve a problem that is a multi-step data analysis. We're going to find some data on the internet, might be HTML, might be an API or whatever, and we're going to write a relatively slow process that's going to pull data slowly, because these are all rate limited. This is a slow and restartable process. So you can start this, and what we're going to do is we're going to have a database that's going to hold the data that we're pulling, and so this might take several days actually, if you really have to do it, and then you'll build up your data in your database, and then what you tend to do is you tend to produce two databases. One is kind of a raw database that, you know, it's all of its data columns are aimed at helping you figure out what you've got to retrieve yet and what you haven't retrieved yet. So that's kind of a crawling, spidering process. And then you find that the data is kind of nasty and ugly, and you find that before you're going to do any analysis, you probably want to clean and process it. So in a lot of these, you're going to go from a raw database to a clean one. And this is going to be really large, and this is going to be really small. And you're going to do this sort of once, but slowly, and you'll do this as many times as you need, changing this program, cleaning the data up over and over and over again. And then you'll end up with really clean data, and that's relatively small. And you might run programs that'll loop through this to do visualizations or analysis or some things or whatever. And so you'll actually sort of use this database as a source of information. Okay? So that's the basic pattern of what we're going to work with. Now, this is what I call personal data mining. And if you're going to do this seriously, Python is used in lots of data mining activities. But if you're going to do data mining seriously with really, really large data sets, we're doing small to medium-sized data sets, as you might do sort of for individual personal research versus like an organizational research where you're processing the logs of a web server or something like that. And there's lots and lots of wonderful technology. And what's really cool is this technology just keeps getting better and better because the whole data mining, data analysis, natural language processing field is just so hot right now. It's so awesome. We're going to keep it simple and do stuff for ourselves for now. And I gave you a bunch of sample code that's going to make it so that you can adapt this sample code to solve the problems that you need to solve. So like I said, this is more of a programming exercise. Data mining might be a lot more complex. If you're doing simple research, this might actually model what you do pretty well. So the first thing that we're going to do is what's called use the Google's JSON API for geocoding. And there are two versions of this. One version requires a key and one version doesn't require a key. Google used to make all this data available for free, but with just a rate limit, but now they're making increasingly requiring a key. So I give you code in this zip file that kind of does both. If you really want to do something in production of taking user entered places and names and getting precise latitude, longitude coordinates, so you can produce a nice little Google map like this. Since Google has made a rate limited API, I've actually pre-spidered a copy of the Google data, and I have my own sort of fake Google API, and so you can do your assignments and test all your code using my fake API, which has no rate limits and has no problems, but it's only a limited set of the data. And so this is the basic process, and it's one of those things that it follows that basic personal data modeling, personal data mining pattern. And so here's this API, which is either Google or me. I've got my own Dr. Chuck version of this, drchuck.net version of this, and there is an input queue of the location. So this is the user data where they just put in the name of where they think they live, University of Tübingen or something. And so this is the queue of the things that are to be retrieved. And in my case, when I built this map for the first time, there was like 15,000. And it took me days to get this. And so it would stop. And so what I would do is I would, read the first one into this geoload.py, check to see if I already had it in my database. If I didn't already have a database, I would go into the API, I'd pull the data down, and I would put it in the database. And then I would go to the next one, the next one, the next one. And so, I might get 1,000 in my database, and then it blows up, or I'm told I can't go any further. So I wait 24 hours, I start it up, and it reads the first 1,000 and says, oh, they're all in the database already. And then it starts at 1,001. And then it adds that, and adds that, and then until it stops. And so it took me several days of processing to get this data right. Now, I didn't have a separate cleaning process because this data is pretty simple. I was pulling out the JSON, the latitude and longitude, etc. And so I didn't have to do two separate processes to clean this data up. It was clean enough right as I pulled it. Because I was talking to an API. If you're talking to the HTML, sometimes it gets nasty and ugly. And so then I wrote this program that just reads through it. It just does a select and reads through the stuff, and it prints out some summary information and tells you what to do. It also prints out, and you'll see this pattern, because I'm visualizing using browsers, HTML, and this happens to be using the Google Maps API. And putting all the data in a little JavaScript file. So these end up being assignment statements in JavaScript. You can take a look at that file. And all the data shows up as assignment statements in the JavaScript. And then when this HTML loads, it reads this file and puts up all those pins, as long as you have access to the in-browser JavaScript API. So the next thing we're going to talk about is PageRank, which is spidering now HTML. We talked a lot about this. Spider HTML, get some links. And so up next, we're going to actually build a real database, full-featured search engine using PageRank. This is another worked code example. You can download the sample code zip file if you want to follow along. And the code that we're working on today is what I call the geodata code. And that is code that is going to pull some locations from this file
we're simulating or using the Google Places API to look places up, and so we can visualize them on a map. And so this is the basic picture. If we take a look at this where.data file, it's just a flat file that has a list of organizations, and this actually was pulled from one of my MOOC surveys. We just let people type in where they went to school, and this is just a sample of them. So this data is read in by this program geoload.py, and if you recall, this Google GeoData has rate limits. It also has API keys, which we'll talk about in a bit too. And so the idea is this is a restartable spider-like process. And so we want to be able to run this and have it blow up and run it and start it and not lose what we've got, right? And so this is unlike some, so we're not now using a database as well as an API, but in order to work around the rate limits of this API, we're going to use the database with a restartable process. And then we'll make some sense of this, and then we'll visualize this. But in the short term, let's start with geoload.py code. Geoload.py, take a look here. So a lot of this hopefully by now is somewhat familiar to you. URL-lib, JSON, SQLite. And so I mentioned that the Google APIs, these used to be free and did not require an API key, but increasingly they're making you do API keys for especially new ones. And so what happens, you can go to your Google Places, go to Google APIs and get an API key, and you can put it in here. It'll be this long, big, long thing that looks like that. And then if you have an API key, you can use the Places API. And I've got a copy of a subset, not all of it, a subset of it here at this URL. As a matter of fact, you can just go to this URL in a browser, and it will tell you a list of the data that it knows about. Okay, and I made it so that that does the same basic protocol with the address, address equals as the Google Places API. So this will just change how we retrieve the data. Either retrieve it from my server. Nice thing about my server, it's got no rate limit. It's really fast, and you're not fighting with Google all the time, and it means that perhaps if you're in a country that Google is not well supported, you can use my API. I mean, that's really strange that somehow my API is more reliable and available than the Google one, but it's true. So we're going to make a database. We're going to do a create table if not exists, and we'll have some address, and we're really just caching the geographical data. We're going to cache the JSON. One of the things we do when we build these processes is we tend to simplify these things and not do all the calculation and parsing of the JSON. Just load it and get it in, and load it and get it in, and fill the data up in this database. And so that's what we're going to do. Because Python doesn't ship with any legitimate certificates, we have to sort of ignore certificate errors. We're going to open the file, and we're going to loop through it and pull out the address from the file, and we are going to select from the GeoData where that address is the address. Let's move this in a bit, and so we're going to do a select and pull out that address. And the idea is if it's already in the database, we don't want to do it, so we do a fetch one and pull out that first thing, which is that will be the JSON right there. If we get that, we'll continue up, otherwise we'll keep going. Pass just means don't blow up, so we accept and we just do a pass. That's like a no-op. And we're going to make a dictionary, because that's what we do for the key value pairs. Everything you've seen so far, I've used constants here, but because we may or may not have an API key, query equals, and then that's the address, and then the key equals, and then the API key. If you recall, URL encode adds the pluses and question marks and all that nice stuff. We're going to retrieve it. We're going to read it and decode it, print out how much data we've got, and add a count. And then we're going to try to parse that JSON data and print it if something goes wrong. And as we've seen, at this top level of this JSON data from this geocoding API is an object, which we'll see a little bit of it in a bit. And it has a status field in it. And the status is okay if things went well. So if the status is not there, that means our JavaScript is not well formed or not how we expect it. If the status is not okay or not equal to 0 results, then print out failure to retrieve and then quit. And then we're simply going to insert this new data that we just put in, and then we're going to commit it. And every 10th one, this is count mod 10, we're going to pause for 5 seconds, and we can hit Control C here, and then we're going to do the geodump. Okay, so let's just run this. Geodata Python. So let's do an ls. So we don't have, oh, we do have, let's get rid of from a previous test, geodata.sqlite. So we'll start with a fresh set of data and run python geoload.py. Of course, I'm always forever making the mistake of forgetting Python 3. So you can see that it's running and it's adding the query, and in this case I don't have the API key, and it's putting the pluses in, and that's this part here with all the pluses. That's the URL and code, and you notice it's pausing a bit. Now it depends on how fast your net connection, this may or may not go so fast, but this is not that much data, so it's like only 2,000, 3,000 characters. And so it's working and talking to my my server. And the interesting thing here is I can blow this up. I'm going to hit Control C. In Windows you'd hit Control, in Linux you'd hit Control C, and in Windows I think you'd hit Control Z, depending on what shell you're working in. But I'm going to hit Control C, and you see I sort of blew it up, right? And causes a traceback, a keyboard interrupt traceback. If I do an ls-l, you can see that now this geodata is there. Now in the name of restarting, I will restart this, and you will see that it checks and skips, and so it runs this code here where it's right here. It grabs it and finds it in the database. So you'll see it say found in the database really quick, chop, 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 and go really fast, and then it'll go back to catching up where it left off. And so all those up there, they did not actually retrieve it because it knew about those things. And so now it's catching up and doing some more and doing some more and doing some more. And then I'll hit Control C. It has a little counter in here that basically, if it hits 200, it stops and you have to restart it. You could obviously change this code. You could make it so it didn't sleep. Doesn't hurt to sleep for like a second after every 100 or so if you want. You could change that code. And now let's just hit Control C and blow it up, ls-l. And there is another bit of code, and this code, it's always good to write these really simple things. And so we're going to import SQLite and JSON. We're going to connect ourselves up. We're going to open, except this is a UTF-8 because it's a UTF. We're going to open this with UTF-8, and we're going to read through. And in this case, we are going to decode. We did select star from locations, and if you recall, locations has a location and a geodata. And so the sub 0 will be the location and the sub 1 will be the geodata. And we're going to parse it, convert it to a string, and then parse it. If something goes wrong with the JSON, we'll just keep skipping it. We'll check to see if we have the status in our JSON. Let me run the SQLite browser here. File open database. Let's take a look at what's in this database. Oh, where are we? Code 3, geodata SQLite. So this is the data we've got. So if you make this a little bigger, if I can I make that bigger? Yeah, it's not going to show us much. So you can see that these are the addresses in the geodata. That's just the JSON. So that's the JSON that we got, and it retrieves it. And so this is a really simple database. That's just a sort of spidering process, run. But now we're going to run the geodump code, which is going to read this and dump this stuff out and print where.js. So it's going to actually parse this stuff. And that's code we've seen before. And so we're actually reading it. And this line goes into the results. Results is an array. So if we go into results is an array. We're going to go grab the 0th item in that array. And then we're going to go find geometry, and then location, and then lat and long for the latitude and longitude. And then we're also going to take the actual address out of the formatted address right here. So in this In this bit of code, we're actually parsing the JSON, and we're going to clean things up, get rid of some single quotes. This kind of data cleaning is just stuff after you play with it for a while, you realize, oh, my data is ugly or does this. I'm going to print it out.